Dear student of class 11, I'll continue with complex number. Now question number 17. Alpha, beta are the cube roots of unity. Prove that 1 plus alpha into 1 plus beta, 1 plus alpha square plus 1 plus beta square equals to 1, that you have to prove. Now say, alpha, beta are the cube roots of unity means to prove this identity, these two are the cube roots of unity means I'll consider let alpha is equals to omega and beta is equals to omega square. It is already given that alpha beta are the cube roots of infinity. Can consider alpha is equals to omega and beta is equals to omega square, or can consider beta is equals to omega or alpha is equals to omega square. Now then I'll take left hand side, 1 plus alpha into 1 plus beta, 1 plus alpha square into 1 plus beta square. Now then I'll substitute the respective values of alpha and beta. Now alpha is 1 plus omega, beta is 1 plus beta means it is omega square. 1 plus alpha is omega square. If I substitute over here, this one will be omega square. 1 plus beta square, beta is omega square. If I substitute over here, omega square whole square will be omega to the power 4. Now then I'll simplify this quantity, 1 plus omega into 1 plus omega square into 1 plus omega square. We can write 1 plus omega square whole square plus 1 plus omega to the power 4. We can write omega cube into omega. Now you know about these things, the value of omega cubed is 1. Omega cubed is 1. 1 into omega is omega. Again we have two dissimilar quantities over here. 1 plus omega and 1 plus omega is 1 plus omega whole square into 1 plus omega square whole square. Now both the quantities I'll write within 1 square, that is 1 plus omega into 1 plus omega square whole square. Now then I'll multiply this two. 1 plus omega square, then omega into 1 is omega, then omega square into omega is omega cubed whole square. Now it is 1 plus omega square plus omega cube is 1 whole square. Now you know what these things, 1 plus, now I'll write in order, 1 plus, now then first I'll write omega plus omega square plus 1 whole square. The value of this quantity, 1 plus omega square is 0 plus 1 whole square. It is 1 square, 1 square is 1, and this is equals to right hand side. Now another important question, question number 19.1. Complex number is given, z equals to x plus iy. It is a given complex number, and the argument of z minus alpha is equals to pi by 4. Find the locus of a complex number. Find the locus of a complex number. It is given in terms of argument. It is not actually alpha. This is a. Z minus a. Now say, we did the theory of argument. Argument means tan theta is equals to y by or a by b by a. Then in this case, you should have a concept that argument means theta. The argument of z minus a is tan theta. Then if you bring this tan over here, this one will be theta is equals to tan inverse b by a. The inverse trigonometric functions that you will do in class 12. Now say, since argument of z minus a is equals to pi by 4. Now then the argument means this is tan. Argument means tan. Substitute the value of z. Z is equals to x plus iy minus a equals to pi by 4. Now then argument of alright, first real, x minus a plus iy is equals to pi by 4. Now the argument means it is theta. Then if you bring this tan from left hand side to the right hand side, now say argument of this quantity I'll write. Now here in this case the argument is this one. Now I'll write in this form. The argument means tan inverse b is a complex quantity. Y over x minus a equals to pi by 4. Whenever you bring tan inverse from like this, if it is tan inverse x equals to y, if you bring this tan inverse from one side to another side, it will be tan y. So you can consider the same thing. I'll apply to you. There is y over x minus a is equals to tan pi by 4, and y over x minus a is equals to tan 45 degrees is 1. Now with help of cross multiplication we can write x minus a. Y is equals to x minus a means therefore the locus is a CUS. Locus is a straight line. We have already done these things in previous videos. What is straight line? What is circle? Locus is a straight line in this case. Now over here one very short and sweet question is there. This is important for the entrance examination. Question number 21, solve. Solve means that you have to calculate the value of z. Over here the unknown is z, the complex number that we are going to calculate. Now 2z is equals to mod of z plus 2i. Solve the following equation is given. Solve means now I'll calculate the value of z using the property of complex number. I'll consider that z equals to x plus iy. Z equals to x plus iy. Now then I'll substitute over here. 2 into x plus iy equals to mod of x plus iy plus 2i. Now then it is 2x plus I into 2i is equals to mod of x plus iy plus I into 2 we can write. Now then 2x plus I into 2i, mod of under root is under root x square plus y square plus I into 2. Now then I'll equate the real and imaginary quantity. Now over here in the left hand complex number the real quantity is 2x. Over here in the right hand complex number the real quantity is x square plus y square. Similarly over here the imaginary is 2i and over here imaginary is 2. Now y is equals to 1. Now you just substitute the value y equals to 1 over here in this equation. You can calculate the value, easily calculate the value of x. X square plus y is 1 square. 2x is equals to under root x square plus 1. Now then squaring both sides. After squaring we'll get 4x square is equals to x square plus 1. 4x square minus x square equals to 1. Now then 4x square minus x square is 3x square equals to 1. Then x square is equals to 1 by 3. Then x is equals to plus minus 1 by root 3. X equals to plus minus 1 by root 3. Therefore, the complex number, therefore z equals to substitute the value of x and y. X is plus minus 1 by root 3 plus I into y is 1. Therefore, the complex number is plus minus 1 by root 3 plus I. This is a required complex number, the value of z. Tricky question, try to understand. Now dear student, again I'll start to find the square root from part B. Now we have already discussed this topic in a previous video, that how to calculate the square root. Now say the square root of 1 minus 2 under root 6i. Now to calculate the square root, that you have to write the factor of root 6. Root 6 means you can write root 3 into root 2 into I. Now we must have 2ab form. Which quantity is a and which quantity is b, that you have to decide yourself. Now I'll consider root 3 is a and 1 minus 2, I'll consider root 3 is a and this whole thing is b. Now then a square plus b square minus 2 AB. Now it is in terms of formula. A square plus B square minus 2AB. If our supposition is correct, then definitely we'll get 1 if I simplify this quantity. Root 3 whole square is 3. Root 2I whole square will be 2I square, then 3. I square is minus 1, it is minus 2. 3 minus 2 is 1. So we are getting this quantity. In place of 1, we can write the sum of the two quantities. A square plus B square minus 2AB means we can write A minus B whole square. Therefore, the square root is plus minus on the root 3 minus root 2I whole square. Root and square get cancelled. It is root 3 minus root 2I. It's the square root of this quantity. Now this one is a little bit different kind of question. Let's see over here. 2 plus root 5I means we don't have 2 over here as well as any number over here. Any even number. So if even number, if it is independent of the even number, what you have to do next is you have to multiply and divide by 2 to convert these things in terms of formula. 4 plus 2 root 5I. Now then 1 by 2, 4 plus 2, I'll consider root 5 is A and I is B. And sum of these two quantities, sum of the square of these two quantity must be equals to 4. Now then I'll write A square plus B square plus 2AB. After simplification of these two quantities, can we have 4 over here now? Root 5 whole square plus I square, is it equals to 4 or not? Root 5 whole square is 5, I square is minus 1, 5 minus 1 is 4. Now we are getting 4 over here. That is, this opposition is perfect. Half. Then A square plus B square plus 2AB means we can write root 5 plus I whole square. Therefore, the square root is plus minus on the root half root 5 plus I whole square. Then the final answer will be plus minus 1 by root 2 root 5 plus I. Is the required answer, or you can open this bracket also. This is the required answer. This was of complex number that we'll do today. Now next video will be of complex number only, and one more video I'll send from complex number, then I'll start another chapter. Thank you.